Okay, start. String. Function string is empty string is just state 0 times, 1 times, and they can be performed in numbers time. Each step we can following do. Alright, so the good string is constructed both have a length between low and high. Okay, so count the group string where the length is between lower and high. Alright, sorry. This is simple. We can do is that 1 either one of the following. Oh, okay, I know idea. So, length. Okay, I have some idea is that it's okay. So idea is dp. Can use dp. So dpi is the number of way that the length is I. dp. No, it's I. Burst of way 0. And I also need more value. Set answer. And so length 0 can going to be 1. Now we have two dp's here. So number of way length the numbers of way add 1 is smaller than the height. That's its height. Bound its height, you can say that height plus 1 add PPI. Do the things 0, 0. Alright. Yeah, I think that should be the idea. Not sure, let's carefully use. Okay. Right, the most profitable path in tree. Alright, let's do part 1. Numbers distinct average. As long as non-empty, find the minimum numbers are omitted. Minimal and maximal calculate average. So first is 0 and 5. Alright, so just use a multi-set. Or we don't use a multi-set, we can start by the distinct average. We just sort n and 2-pointer. Sort and 2-pointer to catch min, max, and the user set. Distinct, right? So we use double. That's fine. So right. That's the idea. I hope it can accept. I just ignore the floating point issue. Right, so yes, set. Okay. And there's a undirected tree. You're given about the age, and age is indicates our age. For the I node, there's a gate. You are also given a rate event amount. Amount represents that its reprise needs to open the gate on I if the amount is negative. Or crash reward. Okay, next slide here. So you know that the game goes on follows. L is at 0 but at the bot node, and at every second need to move to adjacent node. Leap some leaf towards loop to 0 for every node along the path spanning open or separate word. If a gate is already open, no price required. Reaches simultaneously. In our open gate also. Okay. Maximal in-count towards optimal leaf node. So first node is -2. That's -2, and now we move node 1. They reach simultaneously. Why? Oh, okay. So Bob is at the node 3. We move here. So we'll get it's the both. The open get together sure. Now in count add 4 divided 2. All value is event, right? I'm not sure. Amount is event. Amount is event. Have this constraint or not? Amount is event. Okay. Amount is event. And okay. Amount event equals find the maximum profit can reach. Wow, it's interesting. You think about how to do that. The path we need to consider is week and year. Okay, I didn't want to note here. So if it's move to the node 3, things that remain unchanged. Okay, so let me think about the Bob have taken this. Alright, so need to think about how do we do that. And if no, I want to reach and if no. Bob. Okay, so there is some node that let me think about this. The first thing if node. First thing is change the amount. Change the amount. Say this is 0, and we just 2. Just like just going to be here, and if it ever search to this guy's here, what is the depth here? Is the distance event. Let me think. Should we work with? Right, so First thing I want to do is change the amount, but is it easy to implement? Yes. Implement. That's the question, right? Okay, and let's see for string. Oh my gosh, shit. What is? Oh, don't do that. The string, the parser problem, the sync. Alright, so if is this node up to the root, we might change. We might change the values here. We might change the values here, right? And say this going to be 4 and this is 3. The depth is the same as this guy's. That means we cannot do this, right? Because yeah, I think it's 1, it's 2. Let's say if we do DFS 0, 1, 2, we calculate the depth of this node, and okay, so find the path of this. We put depth is event, that means only have one node, right? So only have one node. 0, 1, 3. Okay, so first thing, or have some idea? Yes, okay. Alright, I think I have some idea to implement this approach. So let's change the amount. Let's say find a path and update the node. Update the node, right? And yeah. So this node is Unicode, right? So I update the node. After do that, we just do dynamic programming, DFS. So first thing we build tree. So build tree. Tree node is have size right? And let's find the pass. Okay, so let's say if what? Now return false. Alright, and that's the idea. Okay, so we find a pass. Zero and 91. Okay. Right, so after we find a pass, let's say we have a DP functions of this. Value of the node is null before, right? So we can do that. Okay. Current node, parent node. Do the sensing. This will do the sensing. This is child master. Child maximum resource. Right amount U, and it's consider this. If we choose this leaf node, oh wait, we must sync start rule. They must move to the leaf. Let's do the leaf. So it's oh okay, so it's find a song when reach the leaf node. Right, so answers. You want to maximize the song, right? So just a simple traversal here. It means that only have parent. This is the leaf. We don't need to return anything, so let's say current node is U, we and sum. Okay, that's idea. And let's say pass out. And for the, this is the node we have, right? So the node we have, it's from the there are nothing. And the event is event. Zero, 1. Okay, that's the idea, right? Okay, that's it. A little dirty, but the concept is simple, right? Wow. I think this probably also be hard. Okay. What about parentheses? Loop to the loop. Wow, today's contest, really hard. Okay, so okay, let me think about this. Alright, so based on limit. Okay, so a string and message. Use the split message into one or more parts based on limit. Suffix. Resulting part should have suffix. Where B is to be replaced as total numbers of parts, A is to be replaced as index of the part. What is should be equal to except that's part at most limit. What the fuck is it? The result part should be formed such that what they are concatenating. When the suffixes are removed and they are concatenate in order, this should be equal to message. So this should be equal to message. Alright, and the print part of message will be split into the rest number. If it's impossible to split, return empty. Okay, based on limit, right? So, one or more parts. Total numbers of the part. Say this. What? It's a string. Right? It's a string. Why is this? The first 9 parts. 2, 3, 4, 5, 6, 7. Limit is 9, right? So, suffix should equal to the limit. Starting function form when the suffixes are removed. They are combined together as a send. 114. First, second. The first 9 parts take 3 characters each from the beginning of a string. 3 characters, 1, 2, 3. Yes, by part. Let's keep. Shit. Alright, so let's take index of a part. This 1, 3, 4, 5, 6, 7, 19. We almost did. What is this? Has less 9. Price less 9. Oh, okay. Oh, I have some idea. Limit means that you only can use how many parts we can use. if we use say this is 7-digit 7 and this is 6. Oh, right, so that's interesting. Okay, I understand it. So we'll split the message. We'll split the message, and each part is equal last part is the most, right? So see the last part. Except for the last part, who has left can be at most. This is 7. Alright, so here say limit. Now limit is 9. It's 37. Limit is 9. Consider if we want to divide one part. Can it work well? No. There's 2? No. There's 3? No. 3 parts. Okay, so it's is the 14 part. It says 2, and the mode is wait, it's not. Okay, I may have some idea. I may have some idea. Binary search the part. Say this is index 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means we can split it. This part should be smaller. Alright, doesn't matter given about the part. Divide two part. This is false. Say real string Okay, so is part that is 2. Additional part F1 seems that right, and if additional part say add if say is equal to it's not each time have J. Here is right, if you are saying that the previous part it's message from the index is going to be in J, then you need add 1. This is add number is 1. The suffix part is this at the A is the index, so A is the index to the string, and B is slash at the total part. Okay, so part is add this. So if prefix size add suffix size should be equal to limit. If not equal to limit, then false. And if this is equal to limit, J will add 1. Actually, I think it's we don't need to calculate the unit. That's not good. I think we can do here is that this is the 10. I think well, if status we are saying that this resource is made more nice. If status is 1 means the part is not used. That means the part it's to part not enough. It means we only have 3 parts, but 3 parts cannot do this, so we cannot do. We need more part. Else yeah, that's need more part. We need more part, right? And okay, so how now we used to manage to oh wow, it's a hard coding problem. The concept is not easy, it's not hard, but the implement is very stupid. Okay, let's think. So first thing you need to know is use a counter, right? Okay, so while nouns more than parts, we must do. And yeah, the noun is 1. Okay, and what is a suffix, right? Suffix is now we get a suffix. Okay, and we also have index. Okay, and for each we need to know the length. Need it's topic size. This is integer. We also need this limit. If the length we need is 0, that means the part's too many. So too many should return positive 1. And status too many part. Okay, so -1 is too many part, yeah. And so let's just need prefix and message I plus plus. That should be equal to limit. If number is the last part. That means it's too many. Still be too many. Because we don't have enough character to do that, right? So yeah. Hey, it's true. So if I is not equal to message size, that means too small because too many parts. too many parts. What? Okay, so this is very awesome message. Theory? Why? State as see all the meat happens here. They don't move. 2. Oh, damn, this looks well. Short message. Oh, this is 1. That means the length we need is numbers not equal to parts. And it is 0. Why? Okay, in this case, what happened? Okay. 2 is work. Why? This cannot be empty. There's also be too many parts. Okay, last part cannot be empty. Oh, okay, I may have some missing cases here, so looks well. It should work. What? Oh, why does this work? Because I'm doing here so much of cases. Right. Oh, it's out of time. Always shooting problem. Okay. I don't know. Alright. Too many parts. It's 1, 0 because length we need. Alright, still be here. 2 still be. Right? So dirty here. This need to be rewrite it. But yeah, it works. So only some cases need to be considered. A lot of edge case. Last part cannot be empty. And also, the last part, you need to check that. Yeah, so last part cannot be empty. Okay, so. Okay. Alright. That's it. What are problem 3? Oh, so that's people survey. Since the hard problem is. Okay. Well, this guy is pretty nice. Really awesome. Wow. How do he doing this so fast? This shit problem is so fast. I don't know, but yeah, it's fast. Alright. Okay, let's see the problem 1. So problem 1 and the problem 2, problem 3, problem 4. Okay. So that's fine. Just need some time to code this. Actually, I know a similar problem is LeetCode. Let's say justification. Okay, I forgot his name. Justify. String. It's a hard problem, but yeah, it's matter. It looks about the problem 1. This problem is that you need to do until the numbers become empty, and the average of 2 numbers is AB divided by 2. For example, our average of 2 and 3 is 2.5. You want to find the numbers of this thing average. Where each operation you will choose the highest value, smallest value, and calculate the average of it. So for this example, let's say we just sort them and simulate it using on the set and 2 pointer, add a string, not add a string, add a value, divide 2, you get the answer. Return the set size. This is problem 1. And the problem 2, well, it's a dynamic programming problem. Is that you need to count the way that to build good string, and a good string is a string that constructed by above
process. You can append character 0 times, append 1 times. You want to make the string good between low and high. So you want to find out that how many different good string can build. Okay, initially I have an unsquared approach. Is if we use 1, 0, or we use 1, 1, how many numbers of way are good? We can build this, but actually since the constraint is very big, the 0 and 1 is very big, so we must think another way. Let's think about the length. So DTY definition is that the numbers of way that length is I. So we can build from zero length. Zero length always has a base case is 1. They only have one way to build zero length, and build until the high we can build. Okay, so each length we have 2 operations. First operation is we do 1. Second operation is do 0. So add the numbers of way from DPI. And now after that, we just try to add all of them between the lower and high. That is a good. And that's problem 2. Okay, and the problem 3, it's a little hard, I think. It's you given about a tree, and you also have the value in the tree, and you also have a Bob at any node, and Alice at the root node, and in each second you can move towards to the any leaf node, and Bob will move toward to the root node. And the problem is that since we don't know the Bob, where is the Bob, so we cannot determine which one is greater, right? So it must, if we know the Bob pass to the root, can we change the amount? The answer is yes. So step is find the path and update the amount. So for this example, we say we will update the amount to 0. We update the amount to 2 because this is the odd. If we have 4 nodes, we only update last 2 nodes here. Yeah, so that's a find a path. Okay, and find a path. After we find a path, let's say first build a tree and find a path. Find a path, we just update the path from Bob. And if m is odd, that means divide 2. Okay, and after that we just simple traversal to each leaf node because we want to reach the leaf node to get that what is the maximum profitable. So let's say a DFS. Now let's just try to add a current value, and if this is a leaf node is only have 1 children, 1 parent. So if it's not a root. Oh wait, I forgot a case. It's okay, I only have 2. Okay. Okay, cool. Right, so okay, so if this is not a root node and we only have 1 child, that means this is the leaf node. This is the leaf node. So we update the answers and just traversal. That's linear. This is also linear. Overall is linear. Yeah. Space and time It's linear. Yeah, that's it. Okay. See about problem 4. Right. This problem is that you need to split message into the parts based on limit, and we have a suffix like this, and A is the index, B is the total, and you can do that. Is that if we give you this pattern, can you know how to build this message? If you know the part, you need to be split. That seems easier, right? And the idea is that if we split the more part, the string will be the more smaller, right? And that's too many parts. Let's think about how what is the situation when you split into too many parts of string. Say this is 100, right? And we cannot have any string to take it out from message, so this failed. But this is okay. This is good because we can use 6 length 6, and we still need 3 characters here, and yeah, so we just get 3 characters from the string, and now we get it. So consider that if there are too many, if the part is 1, that means the message is unused. It's not unused. It's called not totally used. Okay, so alright, it's unused, right? If any character in message is unused, that means that you need to split more parts here. So let's see the idea. If this is not equal to message size, that means it's not too many. Oh, sorry, two less parts here. Okay, and yeah, and just by research, the build parts, you see the string and parts. It's say the 14 length is 2. Look at this, and just simulate it for each part. Build from each part as a suffix. And we need to know how many characters we still need to build to fit the limit, right? So fit the limit. So if the limit we cannot fit it, that is too many. It's too many. So return. Otherwise, okay, the peak until the length need is all removed. So if the not last part, and we still have length we need, that means they are not good. That means the part is too many. We need to straight apart. Yeah, so that's the idea. Okay. Okay, let's see. Let's raised. Okay.